So we just experimented without any variables involved. All we did was take our inequalities, we renamed them by making sure we did the same thing on both sides. That's legal. But we discovered that we don't always keep the relationship. So when using inverse operations of multiplication and division to solve inequalities, if you multiply or divide, that's a word that goes in that circle. Anybody think you know what it is? So here we multiplied by -4, here we multiplied by -4, here we multiplied by -2, here we divided by -2, here we divided by -2. Okay, so I'm going to put negative in here when you divide a negative. Divide negative. What's happening? Aren't we dividing by, multiplying or dividing by something? That's the really critical term here. When we multiplied, even when we were multiplying by a positive, when the other number was negative, it didn't affect the relationship. It only affected it when what we were multiplying by or what we were dividing by did it. And now we would say, yes, there's where the negative goes. When you multiply or divide by a negative, what do you think we're going to have to do? So it went from is less than to is greater than. It went from is greater than to is less than. We're just flipping it. We're reversing it, aren't we? The relationship changes from is greater than to is less than, or maybe from is less than to is greater than. So we have to make sure that we're paying really close attention today when we're solving these. When you multiply or divide by a negative number, that's the key word here. You got to make sure that you understand it's by. Okay? So let's look at number 1. What would we do to solve? Now we're just going to use the same thought processes we have for solving equations. What do we do to solve an equation of this type? Maddie? Okay, we divide both sides by -3 because x is being multiplied by -3. So we use the same strategy as if we're solving these one-step equations in one variable. So x is left alone now. And a positive divided by a negative is a negative. Do you agree? Why not?
Because you have to reverse the symbol.
Okay. Why do I have to reverse the symbol?
Because you divided by a negative.
We divided by a negative. We divided by what? -3. Okay, so since we divided by -3, yes, we have to reverse that symbol. It has to go from is less than to is greater than. And this would be our solution. And it's just automatic. As soon as we solve an inequality, we just start our number line, we graph it. And -9 is our endpoint. Integer neighbor to the right is?
-8.
Okay, and integer neighbor to the left is? -10. Okay, so open or close circle at -9. Okay, so don't shade it in. And which direction should we shade?
To the door.
To the door, okay. You don't know your left or your right, you pick out objects. Okay, to the door. Okay. So we say to ourselves, does that satisfy this? If I take that integer neighbor, -8, is -8 greater than -9?
Yes.
It is, isn't it? Now, remember what yesterday in our notes, we did a check problem. And I said, you don't have to show me check problems, but it would be, sometimes it would be in your best interest to do it, especially when you're taking an assessment. And you don't want to have to retake it, which you're going to be doing next Tuesday. So how could we check to see, first of all, do we have a good starting place? Is our endpoint good? What do? Don't we put it in here and kind of like we pretend this is an equation? We say, what is -3 times -9?
Positive 27.
27. So we end up with 27 here. We end up with 27 there. Do we have a good endpoint?
Yes.
Yes. Even though it's not shaded in, we just want to make sure we're at the right endpoint anyway. Then we check something from our shaded region in there. So let's do our -8. -3 times -8. 24. Is 24 less than 27?
Yes.
Now, here's what should happen. This is, I feel kind of crazy when I'm correcting assessments, and students don't take the time to even do a mental math check. I ask them, did you even just do something in your head? Did you check it? And they're like, no, I did everything right. They did what we did in our notes, you know. But yet, if you forget, which it's really easy to do, if you forget to reverse this inequality symbol, you leave it is less than, we would have shaded this direction, right? Correct? Would we have shaded to the windows?
No.
Yes.
So if we had forgotten to reverse it, then negative 10 would have been in the shaded region. So we would have tried negative 10 in there. What's negative 3 times negative 10? 30. Is 30 less than 27? No. So that should be your catch and say, you know what? I either shaded the wrong side or went wrong before that led me to shading the wrong side. I should go back and see what went wrong and just, you know, save myself losing those points. Okay? Go ahead and do the next one on your own. And by the way, you're not going to get to use a calculator in this chapter either. Still going to show me that you know how to work with positives and negatives and without. And you know what? When you have decimals, think about it as money. Maybe that'll help. $6, $1.50. Tell them, buddy, what's the solution for this one? You can't figure out how many $1.50 there are in $6. No, Josh, don't even let that calculator tempt you.
I can't think of
$1.50 and $1.50 is
$3.
$3. Well, there's two of them, and another $3 is $6. So $4. Okay. And then a negative divided by a positive is a negative. The more you train your brain, it'll get there. It will do that someday, promise you. Okay? Should I reverse the symbol?
No.
Why not?
Because we didn't divide by negative.
Because we didn't divide by a negative. We divided into a negative, but we didn't divide by a negative. So we don't reverse it. But let me confuse the issue. Some of us do better if we have to now, if we stop and say, okay, here's my solution, but then maybe we don't, that doesn't work as well for us with graphing. So some of us need to say, you know what, I like it written the other way. So the other way it would be written, x is less than or equal to negative 4. Now I reversed the symbol, didn't I? But did I reverse the symbol because I divided by a negative? No, I reversed the symbol because I'm renaming it. We have to keep it straight. There are going to be times within a problem you might reverse the symbol because you multiplied or divided by a negative, and you might reverse it again because you renamed it, and it ends up backwards started. And you're like, why did that happen? But it's because you got to know when are you reversing it and for what reason. So then graph this would look like this.
No.
No. You want to see how many times I'll see that? You caught yourself doing it yet? I hope not. Open or close circle?
Close.
Oh, shaded to the?
Left.
Right. Windows.
So whoever's listening on the recording is like, I wonder which way the windows are. Okay, so to the left. Why is it to the left? Let's check and make sure then. Negative 5. Is negative 5 less than negative 4?
Yes.
Okay. Is negative 4 greater than negative 5?
Yes.
Okay, so I think we did it. We shaded it properly. Okay. Corey, you gotta stop. Okay, number 3, what are we gonna do? gonna be our multiply by reciprocal. We don't have to mess with reciprocals in this one. Yeah. X is being divided by 6, so we just need to multiply by 6. Yeah, we're just gonna multiply both sides by 6. So negative 1/3 will get multiplied by 6. X over 6 will get multiplied by 6. Crazy thing is, problems like this in the last assessment with equations did not go well. I don't really get it, but okay. So now we can make these into fractions by putting them over 1, right? Well, a positive times a negative on this side is a what?
Negative.
Negative. Can I do this?
Yes.
Is that legal? We're multiplying fractions here. 3 goes into itself once, goes into 6 twice. Can we do that? Okay. And 2 times 1 is? 2. And 1 times 1 downstairs is? 1. And 2 over 1 is really? 2. So negative 2. Should we switch it?
No.
This is negative.
So
You're
you're not dividing or multiplying.
No, it's, yeah, what we were multiplying by is not, so we do not want to switch it. And these guys cancel, and we have x over 1, which is x. And there we go. And once again, you might say, I don't like it that direction. So I'm going to flip it around. We have 2 choices of ways this could be shown. And then go ahead and graph it. I know I don't have to do it for you. You can already do it. So. Okay, you try number 4 now. What'd you get? 14. 14. Greater than? Greater than. So you want me to flip it? Okay, well I actually divided by a negative, but can you also solve this by multiplying by a negative 1 instead of dividing by a negative 1?
Yes.
Yeah, there are 2 ways. When it's a negative 1, you have 2 options. You can either multiply by negative 1 or you can divide by negative 1. Either way, you're still operating with a negative, aren't you? So you need to reverse the symbol. Okay. And again, you know, it really isn't that painful to run a mental math check in your head. The end point, 14 is going to go in up here. And we would put a negative sign. That negative sign is not part of the x. So the negative sign, I think I've shared this with you already. Another way to talk about the negative sign is using the words the opposite of. So this really could be restated as the opposite of 14. What is the opposite of 14? Negative 14, right? So negative 14 on this side, negative 14 on that side. Feeling pretty good about my endpoint. Now I try 15 in there. The opposite of 15 is? Negative 15. Is negative 15 less than negative 14? Yes. See, that's not that painful. Take the time to do it if you don't want to write it down. Lots of you like to say, I like to do it in my head. Well, then do it. Okay, then, you know, try that. Anybody have any questions on anything on the front before you go figure out what you're going to do on the next one on the back? It's yours. Go. You got these skills back from chapter 1, where it's just like solving equations, except we got to keep that little rule in mind. If I multiply or divide by a negative, reverse the symbol. And don't you dare even think about showing me that you're going to divide both sides by a fraction. Because we learned that not always can we really divide nicely by fractions, unless the calculator does it for us. So somebody who's been able to start this problem, will you share with us? Because we've got some people who can't start. What would we do?
Multiply both sides
By the reciprocal of what? 2/3 or -3/4? By 2/3, what x is being multiplied by. So we're going to take both sides. You know, I already know some of you are cramming it right up here because, you know, why would we worry about, using up any paper? That's kind of crazy. And then we'll take 3/2 times the other side also. So this is what we're doing. To undo multiplying by 2/3, we're multiplying by 3/2, right?
What? Because it is.
It's kind of hiding here. This, like, there's that the discussion. Yeah. Is that really make things that bad? Okay, so what happens over here? Well, hopefully that legitimately. Should we reverse?
No.
Why not?
Because you're by
Yeah.
Well, you know what your brain does? It starts like the last 3 problems you had to reverse it, and then you get to this one, you just automatically do it. It's just brains just do that. And a positive times a negative is a negative. Can I cancel these 3's?
No,
No.
Why not?
because
You
there's
don't
one
want them to each other.
You're going to be able to divide the same thing upstairs as you can downstairs. You can't divide across. That's what you're really doing when you're canceling, is you're dividing. So can we do it with the 2 and the 4 then? Because they're downstairs. Maybe they have special, no? Okay, 3 times 3 is? 2 times 4 is? 8. Now, since we have to graph that, it would be kind of nice to give it its other name, which is what?
-1.
-1 and 1/8. This would be a good one to rename as its mixed number because we have to graph it. And this is always interesting. -1 and 1/8 is our starting point. It's our end point. What's the integer that lives over here?
1. Name 1.
-1. And what's the one that lives over here? -2. So which one is this closer to? Is it closer neighbors with -1 or with -2? It's much closer to -1. So maybe we could put it about right here. Because now that's showing 1/8 unit of distance, isn't it? And we need 7/8 more to get to -2. So we got to, like kind of judge. Whoopsie, I got to extend my number line here a little bit. I didn't quite make it long enough. So let's try this again. Whew, all the way out here, I guess. Show me a good number out of 10s. It's only 1/8 of the way over from -1 to -2. And close circle at it, shaded, right or left? Right, is greater than. All the numbers going this way get bigger. Okay? And then we say, oh, this is a very fun one to check. So we skip it and hope that we're right. Is that what we do?
Yes.
Well, we can at least do this. We don't want to check the end point out because that does look kind of, miserable, but we could do it. At least check this. How about we use 0? Is 0 in that shaded region?
Yes.
Just because we didn't label it, does that mean it's not there? It's there, isn't it? So we could use 0. We could test 0. 2/3 times 0.
0.
Is 0 greater than -3/4?
Yes.
Yes. So we don't have to use the integer neighbors. We can use something else that's in that shaded region that would, like, hey, wait, I'd much rather multiply by 0. Okay. Okay, go ahead and write the inequality statement for number 6. 7 is no less than quotient of x and 3. That's all I want you to do. Don't start solving it. I just want you to see if you can set that up properly to start with. 7 is no less than the quotient of x and 3. I will give you no less than 5 days to do your retakes. How many days did I give you? I will give you no less than 5 days to do your retakes. 5 or less? Okay, so if 4 is less than 5, right? So if I said it that way, I would say that if I say to you, I'll give you no less than 5 days to do your retakes, you have to do it in 4?
No.
You can do it in 5. Okay. Or less, so 4? Or 4?
Greater.
So you could do it in 4, but would I give you 6?
No.
No.
I say I'll give you no less than 5 days. Yes. I didn't say no more than 5 days, I said no less than 5 days. Yeah, these are tricky. Okay, so anybody think they know what the inequality would look like for this one? Or inequality is going to be Richard?
X divided by 3 is greater than?
Is that what you want to go with? Is greater than?
Yes.
Okay.
No, I meant less than.
So you.
No, I don't know.
Okay, anybody else want to bail him out here? Blake?
7 is greater than or equal to x divided by 3.
7 is greater than or equal to x divided by 3. Like that?
Yes.
Corey?
X divided by 3 is greater than or equal to 7.
So this is, so I'm just going to write it the way that Corey is saying. So x divided by 3 is greater than or equal to 7. Do those say the same thing?
No.
No.
Yes.
If they trade sides, the inequality symbols can't match. Not if they trade sides, they can't match. Those aren't the same thing. You get to decide which one's right. The first one is.
First one is Blake.
That's right. It is this one.
Oh yeah.
It is this one. Is less than. That's what you guys are thinking. You have to means the is less than symbol. That's true. If that's all it said, 7 is less than. No, this says no less than. That means, you know what, when I said I would give you no less than 5 days to do your retakes, if you want to do them tomorrow, fine, but I'll also give you 5, I'll give you 6, I'll give you 7, I'll give you 8, I'll give you 9. No less than 5. So is greater than or equal to, not this one, okay? So what are we going to do to both sides? Multiply by 3. Multiply by 3. And we should end up with 21 is greater than or equal to x, also known as x is less than or equal to 21. Even when we do these, we graph them. You just get so you just know. You just graph inequalities as soon as you get the solution. And so yeah, you got to be able to figure out those words like is no less than, is no more than, at least, at most. I mean, you got to figure out which inequality is that representing? Okay. Anything you want to go back to? Okay, let's get busy on homework then.